In this video, we are going to talk about the proof of the derivative of x to the n, which is a common algebraic function or algebraic expression that you will see when you are deriving. And we will go ahead and have some example problems of the derivatives of algebraic function. So we will apply the standard formulas that we have obtained for differentiation, and that is the derivative of a sum, the derivative of a product, and the derivative of a quotient. So we will first concentrate on these types of functions, algebraic functions. So let's go ahead and discuss the proof of the derivative of x to the n. So first, we will start off with y is equal to x to the n. Let's go ahead and add delta y and change, we will change x to x plus delta x raised to n. So delta y is equal to x plus delta x to the n minus y. Let's expand x plus delta x to the n using our binomial expansion. So we have x to the n plus n x raised to n minus 1 times delta x plus n times n minus n minus 1 over 2 factorial times x n minus 1 here, so here it will become n minus 2, and then here you have delta x. So in the third term, 1, 2, 3, in the third term it will become delta x squared. So that would be the pattern for succeeding terms of the binomial expansion until it reaches the term delta x to the n, which is the last term. So we will replace y minus with x to the n. So as you can see, the first term and the last term, which is yung x to the n, will cancel out. So observe that all the terms left in the right side of the equation has delta x. Okay, they have delta x, so therefore we can now divide the whole equation by delta y. Delta x, I mean. Let's divide the whole equation by delta x. So here, it will now be simply n times x raised to n minus 1. Delta x will cancel out here because we have divided delta x. And then the remaining terms will now be, so here instead of delta x squared, it will now be just delta x, and so on and so forth until it reaches the last term of the binomial expansion, which will now be delta x raised to n minus 1. So if we get the limit, as delta x approaches to 0, we will now have the derivative of y with respect to x, but all the terms except for this term will be equal to 0 because delta x is 0, so effectively all terms will be multiplied by 0. So finally, we now have n x raised to n minus 1 as our formula for the derivative of x to the n. So that is again, that is a very simple formula. If you will encounter in your problems later on the derivative of x to the n, so it will simply be n. So simply bring down the exponent, multiply by x, and then subtract 1 to the exponent. Okay, so that is the formula for the derivative of x to the n. So let's go ahead and answer some example problems applying the standard formulas that we have derived. So here, this is first the derivative of a sum because they are in addition essentially, okay, and subtraction. So y prime is equal to, by the way, y prime is also the derivative of y with respect to x. So we will conveniently use y prime instead to shortcut this notation. Okay, so y prime is the derivative of x to the 6th with respect to x, the derivative of x cubed plus the derivative of 5x and minus the derivative of 8, which is a constant. So we will just sidetrack first and discuss the derivative of 5x. Okay, separately discuss this first. So that is actually the derivative of c times v, a constant, times v. And let's go ahead and make a standard formula again, no, from our derivative of a product. So product is u v prime plus v u prime. So here we have c v prime plus v c prime, and we know that the derivative of a constant here is equal to 0. So if you will see c times v, then it is simply cv prime. Okay, so let's go ahead. So here 5x will become later on 5 times the derivative of x with respect to x. Okay, and the rest of the terms, this one will become this one. So in the rest of the terms, you can now get the answer. The derivative of x to the 6 is simply 6x raised to 6 minus 1 plus 3x raised to 3 minus 1. Then this one, 5. The derivative of x with respect to x is simply equal to 1. And the derivative of 8 is 0. Okay, so let's simplify our answer. Y prime is 6x to the 5th plus 3x squared plus 5. So that is our y prime. Next example, we have y is equal to v squared plus 3, quantity v squared plus 3 times a quantity v squared minus v plus 1. So here we have two functions multiplied to each other. So let's recall again the formula of the derivative of a product, uv prime plus v u prime. So we have here the derivative of y with respect to v. So v squared plus 3, then multiplied by the derivative of v squared minus v plus 1 with respect to v. Okay, with respect to v plus v squared minus v plus 1 multiplied by the derivative of v squared plus 3. So v squared plus 3, the derivative of our v squared is 2v, the derivative of v is 1, negative 1, and the derivative of 1 here is 0. So again, so let's continue, plus v squared minus v plus 1, the derivative of v squared is 2v. So we have now answered the derivative. Let's just go ahead and simplify our answer. So let's distribute this one. This will become 2v cubed. Okay, 2v cubed minus v squared plus 6v minus 3. Then plus 2v cubed again minus 2v squared plus 2v. Okay, so finally we have 4v cubed combining like terms, then minus 3v squared combining like terms, and then 6v plus 8v minus 3. So that is our derivative of y with respect to v. So let's go ahead to our next problem. We have f of x is equal to x squared plus 1 all over x squared minus 1. So this is the derivative. We will have apply here the derivative of a quotient. So the derivative of a quotient u over v is simply v u prime minus u v prime over v squared. Okay, so I have given you the proof for that in the previous video. Let's just go ahead and apply the formula that we have derived. So we have f prime x is equal to, so first we have the denominator, x squared minus 1, get the derivative of the numerator, x squared plus 1, minus the numerator, x squared plus 1, multiplied by the derivative of the denominator, x squared minus 1, all over b squared, the square of the denominator. So x squared minus 1, derivative of the x squared plus 1 is simply 2x, the derivative of 1 is 0, minus x squared plus 1, the derivative of x squared minus 1 is also 2x. So all over x squared minus 1 squared. So simplify the numerator, we will have 3x squared minus 2x minus 3x squared minus 2x. So divided by the same denominator, we can see here that I can cancel 3x squared. And finally, I now have my final answer, negative 4x all over x squared minus 1, quantity x squared minus 1 squared.